Right, it's me again. Okay, so now we've killed the player, he flies up, drops out the screen. We need to make him respawn. So basically, if dead, we can return out of logic because we don't need to do all of this code. But we do need to check if he's dead, and he's fallen completely out of the game. We want to make him respawn. So before returning, we put if y is less than negative. How far do we want him to fall under the game before respawn? We'll put negative 300. So if he's fallen out the game far enough, we're going to respawn the player. So we just put dead equals false. Simple. Now the game will start doing this logic again, and it will notice that the player's fallen below the floor and respawn him on the floor. Simple. So now if we run it, there you go, landed on. Oh, died. Hang on. Player goes out the left hand side, like, falls down and back up. Might make him fall a bit further before respawning. 800 below the map or the game. We'll just make monster walk into the player. He falls and respawns. Okay, very good. Now what we're going to do is we're going to put in little coins, little gold cubes that spray out everywhere when you kill the enemy and basically act as score for the game. So what we're going to have, create a new class, and we'll call it coin. Grab the enemy code just for this. Actually no, we'll grab the, we'll write the code from scratch. So basically it's going to have, every coin is going to have a double X, double Y position, but it's also going to have X speed and Y speed, so it's going to have momentum like the player. In the constructor, we're going to pass where the coin should spawn, so we're going to pass an X coordinate and a Y coordinate, putting underscores in front so Java knows that this variable is a different variable from this. So we're going to say X equals that, Y equals that. When the coins spawn, they're going to fly up into the air and out sideways, so we're going to put Y speed equals math dot, first of all we're going to set a base level, so it's going to fly up by 3 plus math dot random, and then we're going to multiply it by 12. So some of them will just fall at 3 and some of them will fall at add an extra 12 momentum on based on this random value. The X speed equals math dot random, so multiply that by 2, subtract 1. Now we've got a value between -1 and 1, and we just multiply that by 5. So the maximum it will fly out sideways is at 5. It's going to have a draw method, and we're just going to copy the enemy code. And it's also going to need logic. Oh, just import all of these. There we go. It's going to need logic, where X plus equals X speed and Y plus equals Y speed. And then that should work. The coin's going to be gold, so that's 1 on the red channel and 1 on the green channel. It's only going to be small, so it's going to be 4, 4, 4, 4, and it's only 8 high, like that. So I think that's pretty much the coin class done. So I have momentum, and then it'll, we need to give it a bit of gravity, so Y speed subtract equals 0.4. I think it's a good gravity value. Right, so we're gonna, because we're gonna have loads of coins, we can't just store it in one variable like this. We're gonna store it in a list. So we're gonna have a public static. We're gonna use an array list, and we'll put in the funny angled brackets what type of object it's gonna hold. So it's gonna hold a coin. And we're gonna call the list coins. We'll call it coin list. And then like that. And then spawn the coin list here. So we have to import the array list class. So coin list equals new array list. It's going to hold coins, and it's going to have initial it's gonna. I put the 0 in the constructor because when you spawn a list by default, it will have 10 elements in it. They'll all be null, which we don't want. We just want the list to be empty, 0 when it's created. So this create a coin list empty, and then if there are any coins, we're gonna when we're drawing, we say for coin C. So for every coin, which we're gonna call C, inside coin list, C dot draw. That way it will loop through all the coins in the list and draw them. But of course, if this list's empty, this line won't even bother running. So now we need to test it. So when the enemy dies, just before moving his position, we spawn a load of coins. So we put game.coinList.add new coin, and it's going to be at the enemy's position from when it dies. So when the enemy gets killed, it spawns a coin on its position, then changes its position. So let's test this. Land on the enemy. If I can land on him, there you go. Coin flies out. Do it again. Coin flies out. It's pretty good. But we're going to add quite a few coins. So we're going to say, first of all, we're going to create a random number of how many coins we're going to generate. Double coins equals minimum. We're going to spawn 4 coins. Plus math.random, and we put an extra 15 coins could pop out. And then we do a for loop for integer I equals 0, I is less than coins, I plus plus. And then basically this will just go for a loop, keep adding coins until that number's met. So it can spawn anything up to 19 coins, because that's 15 plus the 4 we're spawning anyway. So I'll spawn the coins and then move the enemy's position. So let's have a look.
I'm nipping out. You listen. I'm nipping out to Harlow.